Hi friends, in this session I'm going to explain uh, the type modifiers that are transient and volatile, and then runtime operator which is instance of. Okay, I'm going to explain on this. You can see transient, volatile and an instance of. That's the heading of this session. The first one we are going to see transient and volatile. Both these are type modifiers, and the other one instance of, that is runtime operator. Okay. So in D, let me create. I'm gonna do all the thing in a program. Before that, let me give a short intro, like what it is. The transient variable, if you take the transient type modifier, type modifiers are Java provides two type modifiers. One is transient and the other one is volatile. So what is transient? So if you use the modifier transient to a data member, what happens, when you try to when we store the object to a persistent storage area, that particular data member which is modified with the transient will not get stored. Alright, so that's the core purpose, to modify a data member with transient. Right, let me repeat it. So what is transient? So if modify a instance variable, that is a data member, with the transient, then when we create an object and try to store that object in a persistent storage area, the data member which is modified with transient will not get stored. Alright, so that is what transient does. Alright, and the other one is volatile. So what is volatile? Volatile, this modify again it applies to a data member, that is an instance variable in a class. So we apply this modifier volatile data member. What happens? The Java tells the compiler that this particular data member which is modified with volatile particular data member which is modified with volatile may have different values. The value of this data member which is modified, let me come again, sorry, what is volatile? This again it applies to a data member, that is the instance variable. Java tells the compiler that the value of the data member which is modified with volatile may change frequently. Alright, so this is the message Java conveys to the compiler. Alright, I believe you got it. So volatile is nothing but Java tells the compiler that the value of the data member that is modified with volatile may get changed frequently. Alright, this is a message it conveys to the compiler. So compiler will get to know that it is a volatile data member, so this value may keep changing. So it has to be updated before it makes use of the data. Alright, fine. Let me show you in the program. And one more, the runtime operator instance of that, even that we are going to see in this instance of. It is just to it is a Java runtime operator just to find a particular object. Just consider a particular instance of the format of this instance of is like object, the keyword instance of, and then the type. So object can be any, can be the instance of a class, and here the type can be a type of a class. So what does it do? Like instance of, it is used to find whether an object is of a specified type, or an object can be casted to a specified type. So let me repeat the what is instance of operator. Instance of operator, instance of runtime operator, it is used to find an object is of a specified type, and an object can be casted to a specified type. So that's the thing it does. Alright, let me show you in the program. I'm just creating a class. The class name is AIO. Okay, so the class AIO, and finish. Inside this class I just declare I comma j. Alright, and one more class BIO. Here you just click on finish. That BIO class is created, and here I do declare a comma 2 integer variables. Okay, then I create now another class, that is the name of the class is CIO, and this class CIO, that extends a BIO. So I give BIO I want to extend the AIO. Okay, so here I type in AIO and it got selected. Alright, and I click on finish. And one more class I create, that is DIO. The name of the class is DIO, and again it extends class A. So browse, I select class AIO. DIO, I create a class DIO which extends AIO. Okay, so altogether I have created 4 classes: A, B, AIO, BIO, CIO, and DIO. CIO and DIO which extends, I mean CIO and DIO that extends AIO. Alright, now I'm gonna create one more class, that is the 5th one class. Here what I do, the name of the class is Instanceof. Okay, and here I make a check on this public static void main, because the program has to get executed. Here what I do, I just create what are all the classes I have created. For all the classes AIO, BIO, CIO, DIO, I create an object for all these classes. Okay, so AIO AOBJ 1 equal to new AIO Similarly for now I have created the object for this. Now I'm going to use here, let me use before I get into instance of, let me show you the uh, transient. Alright, so here I just declare, in this class I just declare a variable int I or int z. Okay, I'm gonna I'm gonna apply the type modifier, that is transient. So transient, okay, equal to 10. So so here you can see the transient, and then the integer, the primitive type int, and then the variable name z equal to 10, the value initialized. So what does the transient mean? Transient, I mean when I create an object for this instance of class, and that object when I store that object in a persistent storage area, that object when I store that object in a persistent storage area, this this integer variable z will not be stored. Okay, that is the purpose of, that is the reason we give transient. Alright, when I don't want to store a particular data member, when the object gets stored, then we go for this transient variable. Right, what is volatile? So I'm gonna use that volatile. Again int, I'll just consider x equal to something 11. What is this? So volatile, as I said, it tells the compiler that this x, the value of x variable, may get changed may get changed frequently. All right. So this volatile modifier tells the compiler that this particular x value may get changed frequently. All right. So that's that's the reason we use volatile. Right. And then now I'm going to use them. So I believe you got to understand what is transient and volatile and how to use them in the real world programming. Okay, so when you write when you store the object in a persistent storage area, you may come to know that when you apply this, it will get reflected. You can't see the z variable in that persistent storage area. As well, this will tell the compiler in a multi-threaded program, this volatile would be useful. All right. And let me show you the instance of. Here what I do, I'm going to use the if statement, if conditional statement. This if, what is the type here? obj1 instance of AIO. Then print system dot out dot print ln equal to obj1 is instance of AIO. See, have a look. Have a look on here. Like I have given within the if statement AOBJ1. This is nothing but an object of AIO. Here I have just created an object for AIO. So I have taken this object AOBJ1. So this object AOBJ1 instance of the keyword, I mean the runtime operator keyword instance of, and then the type is AIO. So I'm just checking this object AOBJ1 is of a specified AIO class. So this object can be I'm just checking AOBJ1 is an instance of AIO, or I mean I'm going to check two things. One is AOBJ1 is an instance of AIO, and that condition, it has to meet that condition, or else it has to meet it can meet the another one. AOBJ1 can be casted, this object AOBJ1 can be casted to this AIO type. So let me repeat, this is an object, AOBJ1 is an object. We're going to check two things. It has to meet either it has to meet any one of the condition. All right, so if it doesn't meet both the condition, then it will return the boolean value false. Okay, so I'm going to check it has to meet any one of the condition. The first condition is I'm going to check AOBJ1 is of a specified type. So AOBJ1 is an instance of AIO. I'm going to check that. And the second one, I'm going to check AOBJ1 can be casted to a specified type, that is AOBJ1 can be casted to AIO. Okay, now here the first condition, it it meets the first condition, that is AOBJ1 is an instance of AIO. So the value would be the boolean value, it would return the true boolean value. So this statement gets printed. Within this statement I am just printing AOBJ is instance of AIO. Okay, I believe you got it. The same way I apply for all the 4 classes. Now I do it for DIO class. I'm just checking here. Okay, now all these conditions, whatever the if statements I have given, it would return the value true, because it meets the first condition, that is an object is of a specified type. So it is of the specified type, so it returns the true value. Here I'm going to check. Now I'm going to give the different condition, that is here I'm going to check uh, what I do, like here you can see I have created one more I'm just checking one more condition. Here I have given the C object, CIO object. So CIO class and DIO class or subclasses of AIO. Okay, so here what I do, a COBJ1, it is an instance of, it is an object of CIO. So that object I have given here COBJ, and then the I'm just checking COBJ is an instance of AIO. Obviously it is not an instance of AIO, because COBJ1, it is an instance of CIO class. Okay, and let us check the second condition. All right, what is but this instance is can be cast, this object can be casted to a specified type. So that is the second condition, that is COBJ1 can be casted to a AIO type. It can be casted to AIO because COBJ1 can be casted to AIO type. Why? COBJ1 is an instance of CIO, and in turn CIO is a subclass of AIO. Alright, fine. So it will this statement, it will return true. So this statement would be rendered COBJ is of instance. Okay. Now I'm just checking here I'm just, let me give B. Okay, and B. So you can see it shows some error message. You can see incompatible conditional operand types bio and AIO. Let me give A and here C. Okay, this what I in this statement what I check, I do check whether the object of AIO object of AIO, that is AOBJ1, okay, is an instance of CIO. Obviously AOBJ1 is not an instance of CIO because it is an instance of AIO. Okay, the first condition it doesn't meet. The second one, what is condition? AOBJ1 is of type CIO. I mean AOBJ1 can be casted to type CIO. AO AOBJ1, it is an instance of A, so A class can't be casted to CIO because it is a parent class, right? So this it will return that this returns boolean value false, and this statement wouldn't be printed. Okay, this statement wouldn't be printed. That is AOBJ1 is instance of CIO wouldn't be printed. Alright, so let me I believe you understand. So instance of operator, runtime operator, it's gonna check two things. The syntax is the first one, the object, and then the instance of keyword, and then the type will be given. So it checks the two conditions. One is particular object, it takes the object, so this object is of specified type. It checks the first condition. The second condition, it checks this object can be casted to a particular type. Okay, so this it checks both the conditions. If it is if any one of the condition is true, it's going to return. If any one of the condition if it meets, then it's going to return the boolean value true, otherwise it returns false. Okay, I believe you got it. Let me run this program here. Run this program. The program gets executed and we got the output. Okay, here you can see AOBJ1 is of instance AIO because it is an instance of AIO. The AOBJ1, it is an instance of AIO. That's what we created. So it checks for the first condition, it meets. So it returns true, and this statement, you can see this statement. This one it checks. Okay, AOBJ is instance of AO. Obviously AOBJ1, it is an instance of AO. We have created here. You can see AOBJ instance of AO, right? So when it meets the condition, here it meets the condition, first condition, so this statement gets printed. OBJ is instance of AOBJ1 is instance of AO. Okay, the statement gets printed. Fine. Similarly, it checks for this, the second if condition, and third, and all the classes are checked, and it got printed. All the result would be true, and it got printed. And the final two things we do here, we check for C object can be casted to A. So it returns, you can see C object can be casted to A because C, it is a subclass of A. CIO, it is a class of AIO, so that's the reason this here this statement gets it returns a true boolean value true, so this statement gets printed. So COBJ1 is instance of AIO. Here you can see this. COBJ is instance of AIO. Okay, and this statement and the other next if condition, it checks and it returns a false value. That's it returns the boolean false value. That's the reason this statement system OBJ1 is instance of CIO. It is not printed in the outstream because A can't be casted to C. The reason is AIO, it is a parent class. AIO object can't be casted to a CIO type because AIO, it is a parent class, and CIO, it is a subclass. All right. Okay, fine. So so this session would have given you enough knowledge on the type modifiers transient and volatile, also the runtime operator instance of. Alright, let me catch you with different topics in the upcoming sessions. Please do subscribe to the channel Java Track, and if you like the session, please share with your friends and well wishers. Alright, thanks for watching. Have a nice time. Bye bye.